Hello everyone, I'm Miguel and I'm going to start the presentation of the project Modeling and Simulation of Robotic Luggage Transport at OPO Airport. This presentation will follow the order presented on this slide. First, I will give a brief introduction about AGV, introduce the airport, and then explain the implementation carried out in the project, as well as the results of it. Finally, I will demonstrate a short video with the features and the conclusions. This project came from the interest in carrying out work in the field of industrial robotics, and a task that involves a great intensity of manual work in this area in adverse conditions is the handling of luggage in airports. In particular, its transport to and from airplanes. Therefore, due to the increasing shortage of manpower, the objective of this work was to automate this task using mobile robots. Before entering the project, I will just explain the main difference between an AGV on the left side and a mobile robot on the right side. The big difference is basically the use of predefined paths, that is, the previous planning of trajectories. If an obstacle appears, it is necessary to change the trajectory on the AGV, while on the mobile robot it will perform control autonomously. For the software, several simulation software for mobile robots were compared, such as FlexSim, Visual Components, Simu, Simulate, and AnyLogic. To make the project more realistic, it was necessary to find one that allowed 3D editing and import of CAD objects. The main requirement was that it should be able to use mobile robots and that it should be also possible to plan trajectories, since the project includes several AGVs going to multiple locations. Therefore, as you can see on the table, the only software that meets all the requirements was FlexSim. That is why it was chosen. The airport chosen for the project was the Francisco Sá Carneiro Airport, more known as OPO Airport. Located in Porto, it is the second largest airport in terms of air traffic. It is important to mention certain characteristics of the airport that will be used in the project: the amount of baggage per passenger, the number of passengers per flight, and most important to this project, the amount of baggage per flight. These values vary from company to company. However, as you can see in the table, the average amount of baggages per flight is 79 units. In this slide, you can see the FlexSim aspect. Basically, in this figure you can check several things: the layout of the airport, the start and end locations for the arrival baggages, the start and end locations for the departure baggages, the 9 stands closest to the terminal, the AGV route on the left low side of the figure, and, of course, the airplane route. Regarding the project, I will highlight the most important points of the constituents, that is, the loading and unloading times for the AGVs, the capacity of the airplanes, and what is a flow item in the case of the packages. Regarding the AGV, the type of the AGV chosen is what is represented in this figure, the underride. It is one of the solutions to perform repetitive tasks such as transporting loads from point A to point B, and that's exactly what happens in this project. The speed of the AGV differs from the situation they are in, whether straight or curved, and whether they are loaded or unloaded. All of this can be seen in this figure. The following rules were used. In the curves, the AGV will move at half of the speed in relation to the straight line speed, and the same happens when it's loaded. The AGV will travel half as fast as when it is unloaded. The time that an AGV will take to load or unload a bag is 10 seconds, and they can carry a maximum of 20 baggages at the same time. The airplanes have the appearance depending on the company. In these figures, you can see the 5 examples used in this project. The number of luggage they carry will vary between 66 and 83 units per flight. In these diagrams, it is possible to see the mechanism of the project and understand the routes of the baggages. They are divided into two groups, the arrival and departure. On the left side, starting with the arrival, the plane arrives at the airport and makes its journey to the respective stand, unloading their baggages. The AGVs will go to that same stand and load the baggages. Finally, they travel into the terminal and unload their arrival baggages. On the right side, we have the departure baggages. The route is exactly the opposite. The baggages will arrive at a defined location in the terminal, the AGVs will travel to them, load, and proceed to the stand where an airplane is located. Then, they unload the baggages, and they are loaded into the plane, and the plane starts to leave the airport. To implement the baggages into the project, it was necessary to create them as a flow item. And what is a flow item? It's basically an object that will be used from the beginning to the end of the simulation. When creating the baggages, a destination field is also used, which will be used by both AGVs and planes to know to which stand they must transport their baggages. Starting with the departure baggages on the right side, it was necessary to create them and send to the local list bagagens deste whenever they appear in the terminal. While for the arrival baggages on the left side, it wasn't so simple. It was defined that 5% of the created baggages are priority. And what is this priority? It's basically the first ones that will be transported by an AGV and whenever a plane arrives. To differentiate themselves from the others, their size was increased in the simulation. Finally, all of them are sent to the respective local list bagagens. In the lower right corner, a table was created that will appear on the slides of the implementations of the remaining flows, to facilitate the understanding in the different lists created. For the implementation of the flow of the planes, it is necessary to wait for the baggages to arrive, so they can start their journey. In the case of the arrival baggages, on the left side of this flowchart, they will pull the baggages from the local list bagagens, and after that, the plane can start the journey towards one of the stands. Within a run-sub flow, it is unloaded and sent to the global list Bagagens de outro aero. This list will also be used by the AGVs in the future to pull the baggages. A run-sub flow works like this. Basically, the token inserted in the run-sub flow task is like a parent token and makes it wait for all the child tokens to run out before moving on the next activity. In this example, the parent token is the baggage group and the child tokens are the bags in and destino descarga. Returning to the same process flow, a local list was also created to know how many planes are in the terminal, called aviões no terminal. This list is used to decide to which plane will carry the baggage that will be transported, and this is always be the one on the stand where the baggage is, that is, the closest to the place. If this method was not implemented, the software would use the plane that has been in the terminal for the longest time. Then, for the departure baggages on the right side of this flowchart, it is necessary to wait to be already more than 65 baggages ready to be transported by the plane. After that, it is necessary to pull from the global list bagagens deste aeroporto. These baggages are entered in the list by the AGVs. It is also necessary to pull from the list created earlier and check which planes are in the terminal. Then, it is necessary to load the baggages and start the departure flight. Regarding the flow of the AGVs, similarly to what happens with airplanes, they will only move when there is baggage to be transported. The AGVs are divided into two groups with the same number of elements. That is, if they are 10 AGVs, they will be divided into two groups of 5. This method was implemented for two specific situations, when two flights arrive practically at the same time, and for cases where baggages appear at the terminal at the same time a plane arrives. Starting with the arrival baggages on the left side, the AGVs will check which stand they are in through the cycle that has the conditions of the arrival baggages. In this slide, it is the chegada bags bigger than 0. If this condition fails, the next stand is checked until the stand with the baggages is found. Once found, the baggages are pulled from the global list Bagagens de outro aero, and the AGVs will travel to the stand. Within a run-sub flow, the AGVs will load the baggages, transport it to the terminal, and unload the baggage at the arrival point. When they return to the terminal, there are a series of conditions and confirmations to check if there is still any baggage in the stand. If there is, only one AGV will carry out the transport. If not, the AGVs will wait for more baggages to arrive. In the case of the departed baggages, on the right, the AGV will pull from the local list bagagens deste, and then load the baggages. After being charged, the AGVs move to the stand. At the stand, they will, again, within a run-sub flow, unload the baggages and send it to the global list Bagagens deste aeroporto. This list was previously mentioned in the flow of the planes and is used by them to receive the baggages before taking the departure flight. As with the arrival baggages, there is a cycle to check if there is still any baggages to be transported in the terminal. If not, the AGVs will just wait for more baggages to arrive. After demonstrating the implementation, I will now present the test scenarios. Tests were performed from 13 AGVs to 17. The results obtained can be seen in these tables. The first table represents these values in seconds, while the second table presents the same values in minutes to be easier to understand. As it can be confirmed, the maximum waiting time for the baggages reached values above 17 minutes until the test with 15 AGVs, including this one, while in the scenarios with 16 and 17 AGVs, the time dropped to around 15 minutes. The minimum waiting time for baggages, whether they are priority or not, was always the same through the scenarios. This was to be expected, given that in the priority baggages, regardless of the AGV numbers, they will always be the first package to be unloaded. What changed over the different scenarios was the average waiting time for the baggages. This through the day dropped around 3 minutes per flight between the first and the last scenario. It seems insignificant, but if you calculate the total time over the course of a day, 3 minutes on each of the 43 flights performed in the simulation results in almost 2 hours of difference just carrying out packages. Due to this factor, and the fact that the maximum waiting time is much lower, it was decided that the best scenario for this day was the last one, with 17 AGVs. It is also important to mention that part of this time is due to the journey of the AGV itself, between the stand and the terminal. The time varies depending on the stand where the baggages are located. Since, if you go to the first stand, the AGV will be loaded for longer than the times will go to the last stand. For example, if the trip takes place at the first stand, the AGV will lose an average of 10.5 minutes for the trip, while if it is on the last stand, the AGV will lose approximately 9 minutes in travel. This is due to the difference in speeds between the AGV being loaded and unloaded. Now, let's see the video that shows everything that I talked so far. As previously mentioned, this queue will be where the arrival baggages appears. I will demonstrate the difference in size between a priority baggages and a non-priority. Only after the arrival of the plane, the AGV will start the journey to the stand, and it will be possible to verify that the priority baggages are the first to leave the plane. As you can see, the first AGV takes the priority bags and the other ones takes the rest of the bags. Then, for the departure baggages, it is possible to verify that these will go to the stand and the plane that is on that same stand will continue with the baggages. At this point, it will be also possible to verify one of the specific situations mentioned in the method of implementing two AGV groups. While one of the AGV groups will load the baggages for the departure of a flight, the other group will, at the same time, unload the arrival baggages for another flight. Then, let's see the departure of a plane, where the baggages will be deposited in the sink that simulates the departure from the airport. The sink is that left one on the video, exactly this one. Finally, it is also possible to check the list of the planes in the terminal referred in the implementation of the flow of the planes. There are 4 planes in the terminal, it will appear that there are 4 items in this list. To conclude, as ideas for future development, I have 2 that will enrich the project. The first idea will be to implement this system at more points in the airport. That is, instead of just reaching the 9 stands that are closest to the terminal, also reach the remaining points where planes can stop. The second idea will be to implement the usage of baggage in transfer. These are baggages that their destiny isn't at this airport, and they are immediately transferred to another plane. This situation happens on stopover flights, and with this I finish my presentation. Thank you.